Welcome to homework questions 38 through 42 in Core Connections Algebra. Question 38. Chari performed a series of jumps on a trampoline. Her coach measured the height of each jump. The coach's data was recorded in the table at right. We're looking to make a graph of the data, fully describe the graph. If the pattern continues, what are a reasonable max and min for the graph? And then which family of functions could model this data? And you can look at the math notes at 112 if you need some help. So let's start by making a graph of the data. So I have a graph down here. I only have quadrant 1 because everything's positive. We have the jump number, which would represent our x values, and the height, which would represent y. So we're going to plot 1 and then 0.5. Now, since my y values only go up to 5, I'm going to go ahead and just make every square represent a half a unit. So I'm going to mark that down to indicate that. We need to make sure we label. And then I'll do the same thing on the other side in terms of the x-axis, even though we don't have half units in terms of the number of jump. And then we can plot the points. So we have the point 1, 0.5, so that'd be about right here. 2, 0.9. 3, 1.6. 4, 2.9. And 5, 5.2. So about right there. So we've made a graph of the data. Now we might question as to whether we should connect the points, but are there jumps in between 1 and 2? So are you going to have a 1.5 jump or a 1.2 jump? And since we don't, we're just going to plot the points. We're not going to actually try to connect them. So that's part A. Part B, we want to fully describe the graph. So we can do a couple different things. We can talk about the shape. So we can say the graph is curved. You might try to describe or talk about maybe what function it belongs to, but let's just keep it in simple in terms of the points look like they're going to form a curve at least. What else could we say? We could also say as x increases, what happens to your y value? Y also increases. It doesn't appear we have an x-intercept or a y-intercept. If anything, we could say at jump 0 we had a height of 0, so we possibly could say that the graph would hit at the origin, but it's not part of our table, so we won't include that right now. Doesn't appear to have any symmetry. And so for right now, it's, intercepts. It's about it looks like, in terms of what we can say. The next part is C. If this pattern continues, what are a reasonable max and a min for the graph? Well, as you can see, these points, we don't have an exact value that they're going up by, but how high can you jump on a trampoline? So maybe by jump 6, maybe we're getting close to 10 or something like that. So one of the, we can say maybe that the max, we're not obviously sure, but the max could possibly get up to, 10 feet maybe. All right, that would be the highest that she could jump. And then the min, that will be a value of 0 feet because you haven't jumped yet, so you're still on the trampoline. And then part D wants to know which family of functions could model this data. And if you go back and look at the math notes, I'm going to draw it in and then I'm going to take it out because they don't connect, but it looks like that, which would be considered exponential. So it's part of our exponential function family. And so now we've gone through all 4 pieces of the question. Question 39. Use the idea of cube root from problem 1-35 to evaluate the following expressions. So once again, go back to 1-35. And what does a cube root mean? So as you might recall, the cube root of 1, we're looking for what value gets multiplied by itself 3 times to give you 1. And the only possible answer that could be would be 1. So the cube root of 1 is 1. What about the cube root of 0? Same idea. What number times itself 3 times is going to give you 0. Now 0 times anything is 0, but these numbers have to be the same. So the only way that's going to work is if you take 0 times itself 3 times. So the cube root of 0 is 0. What about the cube root of 2 cubed? Well, we could rewrite this to kind of help us out. 2 cubed is 2 times 2 times 2, or the cube root of 8. So what number times itself 3 times gives you 8? Well, if you look at it, that's what you just expanded out. 2 times 2 times 2, so there's 3 of them, is 8. So therefore, the cube root of 2 cubed would be 2. And then you can kind of apply the same thing on D, is that 7 times 7 times 7. Don't necessarily know what that is. I could plug it into a calculator. But then when I go to do the cube root of that, it's just going to break it right back down to 7. It's 7 times 7 times 7. That will give you that answer underneath the radical. Question 40. Solve the equations below for x and check your solutions. So in part A, we have negative 6 plus 10x equals x plus 12. We're going to get the variables on the same side. I'm going to do that by subtracting x. Remember, you can solve the equations in different orders here, so it doesn't have to be exactly this way. Get the constant on the other side, so we're going to add 6x to get 18, and then since it's 9 times x, we're going to undo that by division, and x would be equal to 2. And it does ask you to check your solutions, so to do that, to check your solution, you're going to plug in 2 wherever there's an x into the original equation, and then just simplify both sides. So we got negative 6 plus 20 is equal to 2 plus 12 is 14. Negative 6 plus 20 is 14. So 14 is equal to 14. As long as you're left with a true statement like that, that means that the answer is correct. So on to B. 10 plus 5x is equal to 2x minus 11. I'm going to go ahead and subtract 2x to both sides. That's 10 plus 3x is equal to negative 11. I'm going to subtract 10. So every time you're seeing that we're getting the variable term on one side and the constant on the other. And then we'll undo that last step by multiplication or division and get x equals negative 7. So once again, to show that check, this would be 10 plus 5 times negative 7 is equal to 2 times negative 7 minus 11. So 10 minus 35 is equal to negative 14 minus 11, or negative 25 is equal to negative 25. So once again, it does check out. On to part C, we have negative 9x equals negative 3x plus 18. Add 3x to both sides. That's negative 6x equals 18. This one we only had to move 1 because there was only one constant, and then we can divide by negative 6, and x equals negative 3. And then, as always here, let's go ahead and check. Negative 9 times negative 3 should equal negative 3 times negative 3 plus 18. So that'd be positive 27 is equal to 9 plus 18. Is 9 plus 18 27? And it is. So 27 is equal to 27. And the last one on D. We have 2x minus 9 is equal to negative 7x. So I'm going to subtract the 2x. That way, that leaves me with the constant on the left and the variable term on the right. Divide both sides by negative 9. X is equal to 1. And then, as always, we continue to do our check. 2 times 1 minus 9 equals negative 7 times 1. So 2 minus 9, and that's equal to negative 7. And so we see negative 7 is equal to negative 7. So make sure if it tells you to check your solutions, you need to show that. Find y in each equation if x is equal to 16. Alright, so on part A we have y equals 3 plus the cube root of x minus 8, but x is going to be equal to 16 in all these problems, so 16 minus 8. And then we can simplify. 16 minus 8 is 8. So to do this, we need to know what the cube root of 8 is, which I know we did earlier, but remember we're looking for numbers that multiply by themselves 3 times to give you 8, and that means x would have to equal 2. So this will be 3 plus 2. So therefore y would be equal to 5. On part B, we have y equals the square root of 16. Still plugging in 16 for x. The square root of 16 is 4. What times itself gives you 16, so that would be 4. And then 4 minus 7 is negative 3. And then the last one on here, C. Y is equal to 4 plus, that's the absolute value of 9 minus 16. So we're dealing with three different types of functions on A, B, and C. A is a cube root, B is a square root, and C is an absolute value. So this would be 4 plus the absolute value of negative 7. You have to evaluate the absolute value before you move on. So the absolute value of negative 7 is 7, and y is equal to 11. And so I'll just remind you that on this first one, this is a cube root function. The second one is a square root. And then the last one is an absolute value. So if you're curious of the names, that's what we would be calling them. Question 42. Use your graph investigation questions from problem 1-32 to describe the graph of the quadratic function y equals x squared plus 8x plus 7, shown at the right. So go back and look at your learning log and that question 1-32 and look at what ways we use to describe a graph. And so this one is a parabola, so we'll talk about its shape, we'll talk about the important points, is there symmetry, is there a max or a min, things like that. So that's what we're looking to do here. So first off, what graph are we talking about? Well, this one is a U-shaped graph, which is called a parabola. All right, it does open up. So we can have it open different ways, but this one does open up. We also notice there is a minimum value down here, which is also called your vertex. You have some x-intercepts, and you also have a y-intercept. Is it symmetrical? Yes, you can reflect it over that line. And so, once again, those are the things that you're going to write down to describe the graph. And so I went ahead and wrote all those down that we just kind of ran through. The graph is a parabola open up. The vertex is at -4, -9. Remember, this is your minimum value of the parabola. It doesn't get any lower than that. It has a vertical line of symmetry. And since it crosses at x equals -4, that would be the line of symmetry. And then the x-intercepts, where the graph crosses the x-axis. And then the y-intercept, where the graph crosses the y-axis. The y-intercept is a little bit tough to see in that picture as well. Could have talked about other things, how the graph decreases up until x equals -4 and then increases after that. We could have talked about it being a function possibly, but we're still building on some of those descriptions. So for now, this is a pretty good list of describing what we know.